We are on 5.3. I'm going to give you some examples with some roots and examples with finding the square roots and using those square roots to solve quadratics. Before we really um, get started here, basically this is what I want you to do. I want you to make a little checklist here, and these are common square roots to remember. You have the square root of 4, and that equals 2. You have the square root of 9, and that equals 3. We have the square root of 16, and that equals 4. You have the square root of 25, that equals 5. You have the square root of 36, and that equals 6. You have the square root of 49, that equals 7. You have the square root of 64, and that equals 8. You have the square root of 81, and that equals 9. You have the square root of 100, and that equals 10. Square root of 121 equals 11, and square root of 144 equals 12. Here's basically what I'm going to tell you. You're in my class. You need to have these memorized. You need to remember each and every one of these. And why? Because this will make simplifying roots so much simpler and so much easier for you if you remember these. That's the whole purpose behind this. You need to remember these. If you do, then you shouldn't have a problem. Okay? So keep those into memory. All right? It'll help you regardless of whether or not you have me in class or not. So, next up, here's what you're supposed to do. Okay? You got 175 there, right? First of all, before we do square roots, I want you to keep in mind that there are multiple ways to solve these problems. There's not just one way. Okay? So what I want to do is here, I'm going to show you a couple ways to solve the square root of 125. And what that means is simplify it. So you got to remember keys to simplifying as well. And me personally, I remember that most things that end with a 5 are probably divisible by a 5, right? So 175 divided by 5, well look, I was right. 175 divided by 5 is, I get a 5 and a 35. Well, keep in mind when you simplify, you have roots. So this equals the square root of 5 and the square root of 35. 5 times 35 is 175. That's where I'm getting this from. Square root of 5. Can I take that down any farther? The answer is no. And the reason why is, what are the things that I can split up 5 into? 1 and 5. Just gives me exactly what I have, so it doesn't help at all. 35. Once again, using the same concept and the same rule, it ends with a 5, so more than likely it's divisible by a 5. And I'm right. This is a root 5 and a root 7, because 7 times 5 is 35. Can I take 5 any farther? No. Can I take 7 any farther? No. And here's another reason why. You want to know why I can't take these any farther? Because they're prime numbers. When you get down to a prime number, you can't take it any farther. That's it. Okay, that's all it can be. So this is what we have. Square root of 5, square root of 5, square root of 7. Okay? Now, how does this help me out at all? Well, I'm going to teach another little rule with square roots. Okay? Square root of 2 times the square root of 2. Well, what that means is you multiply what's underneath the roots, and you end up getting square root of 4. What is the square root of 4? 2. Square root of 3 times the square root of 3. Well, you multiply what's underneath, and you end up getting a 9. What is the square root of 9? You should know that because I told you to keep it in heart. Right? Keep it in mind. Memorize it. Well, that's 3. Well, look at a little pattern here. When you have two of them that are the same, look what your answer is. Whatever was underneath. When you have two of them that are the same, look what you get for your answer. A 3. Well, look at this. I have two that are the same, which means I end up with my final answer as 5, and I have a square root of 7 left over. And there's your final answer to that problem. So kind of picture them as one of the teachers at our school that I work at brought this to mind. He calls them marriages. Think of it in mind as these two fives are getting married to each other and they become one, right? You got a root 5 and a root 5. So pairs of roots kind of cancel out and just leave what's underneath, which gives you 5 root 7. Here's another way you can think about it. If you remember your common roots, square root of 25 is a common root, right? 25 times 7 is 175. What's the square root of 125? That can simplify to 5. 5 root 7. I'm done in one step. That's another way you can look at it. Alright, so me personally, taking a look here at this, I'm trying to think of something in common as quick as possible. If it ends in a 0, it's divisible by 10. So, just trying to think of something quick off the top of my head. I know a 10 goes into it, so I got root 10. And 10 times what gives you 320? 10 times 32. Can I take 10 down? Remember, you got to take them down to prime numbers. So, can you think of two numbers that multiply together to give you 10? I can. 2 and a 5. Square root of 2, square root of 5. Notice how those are both prime, so I know they're done. Over here, what's the first thing that comes to mind for 32? For me, root 4 and root 8. Why? Because 4 times 8 is 32. Square root of 4, right? That's one that I told you to keep in common in your head. I told you to keep that in head. Square root of 4 turns into a 2. I told you to keep those in your head. 8, what can I write that as? I can write that as square root of 4 and square root of 2 because 4 times 2 is 8. Square root of 4, I just told you to keep that in your head. That's a 2. So here's what we have. I have a 2. Sorry, I have a root 2. I have a root 5. I have a positive 2 and a positive 2 and a root 2. That's everything. 1, 2, 3, 4, 5. Well, I have a root 2 and a root 2. Right here, what's a root 2 times a root 2? That gives me another 2. So really here's what I'm staring at. 1, 2, 3 2's, and I have a root 5. What is 2 times 2 times 2? 8. 8 root 5 is your final answer to this problem. 8 root 5. Or, once again, if you remember your common roots and you know what's divisible, I know that 320, 64 goes into it. 64 and 5. Square root of 64, square root of 5. What is the square root of 64? 8. 8 root 5. Already done in one step. This is why I'm trying to get you to remember those common square roots. If you can find the highest common square root that goes into that, you can be done in one step. And quickly over here, looking at this one, I'm using the concept of the highest possible square root. What's the highest possible square root that can go into that? 9 and 2, right? What's the square root of 9? 3. So you're done already. 3 root 2. Or you could have done this as, I know that 3 times 6 gives me 18. I can keep going with this. That's a prime number, but this is not. That's a root 2 and a root 3. Now these are all prime. I have a root 3, a root 2, and a root 3. When I put them together, they're the same, so I get 3 root 2 as my final answer. So there is some questions with simplifying roots, and I will stop there. But if you have any further questions with simplifying roots and understanding how they go, please feel free to email me.